Hey everyone, we are doing a lesson today on Lewis dot structures. So by the end of this lesson, you should be able to identify elements based on their dot structure. And before you get started, you may want to review valence electrons, cation and anion charges, and then Hund's rule. So, excuse me, we're going to jump straight in with electron dot structures. They're also referred to as Lewis dot structures. And to write these, you write the element symbol and then you put dots on each side like a box. So you'll have dots on the top, the bottom, the left, and the right, not in a circle. They only show your valence electrons, so the most that one symbol can have is 8 dots. And then you're going to place one dot on each side of the symbol before filling up. So this is like Hund's rule. So just kind of review that. Also, you can only put 2 dots on each side, so that kind of follows Pauli exclusion. So again, review those if you don't see that connection there. Sometimes, and I will say that way is how I was taught. You put one on each side, then you go back in and fill them up. But sometimes you can partner up the first 2 electrons because they are assumed to be in the s orbital, so they would be buddied up first, and then you could fill up the other 3 as needed. You would get credit either way here. So here's an example of what a dot structure looks like. So this is for argon. We've got our symbol AR in the middle, and it's in group 8A, so it has 8 valence electrons, which means it gets 8 dots around it. And that's all you have to do. Dot structures are very easy. So we're going to do the dot structure for potassium and boron. So your first thing is to write the element symbols. So for potassium, it's K, and for boron, it's capital B. Then you need to count up just the valence electrons. So potassium's in group 1A, has 1 valence electron. Boron is in 3A, 3 valence electrons. Then you draw 1 dot on each side before filling up. Now, keep this in mind as well. I don't care what side you start on as long as you have the right number of dots. Okay, so just because mine may start on the left or on the top does not mean that you have to start on the left or the top. Okay, sorry, you might hear my son crying in the background a little bit. So for potassium, we have 1 dot, so we're going to put it on one side. It does not matter what side you've got it on, but it's around your element symbol. For boron, you can put 1 on each side before filling up. Again, it doesn't matter what side you start on as long as you got 3 dots. Or, like I said, you can partner up the first 2 because they would be considered in the s orbital and then have that last one by itself. So it does not matter. I cannot stress this enough. It does not matter what side you start on. And then I want you to try to draw the dot structures for chlorine and krypton. So pause the video and try that. Now, before we move on to ion dot structures, I do want to make something very clear, which always tricks people up with these dots. We know for valence electrons, we can look at the group number, the A group number, and that tells us. So if you're in group 7A, you got 7 valence electrons. Group 2A, you got 2 valence electrons. Do not forget that helium is in group 8A, right, because it's a noble gas, but it only has 2 electrons. So even though it's in group 8A, it will not have 8 dots. It only has 2. So make sure you remember that because it tricks people up all the time. So now that we know how to draw dot structures for elements, we can also draw them for ions. So remember what ions are: having a charge, losing or gaining electrons. If you draw the dot structure for a cation of any charge, any positive charge, it will have no dots around the symbol because we lost those valence electrons. If you have an anion, you should have 8 dots around the symbol because you gained electrons to fulfill that octet rule. The difference between these dot structures and element dot structures, other than the fact that they'll have, other than the fact that they'll have 0 or 8 every time, there's not going to be an in-between there. It's either 0 or it's 8. The other difference is you will put these symbols in brackets with the charge on the outside of how many dots they gained or lost. So this is an example of a cation for sodium. So we know sodium forms a cation. It lost its 1 valence electron. So you just have the symbol with no dots inside brackets and the charge on the outside. Chlorine gained an electron, which means it filled up to 8. You put brackets around that symbol with a charge on the outside. So we're going to do an example of drawing the dot structure for calcium ion. So first is you need to determine the element symbol. So for calcium, it's Ca. Then you need to determine the ion and the charge. Calcium is in group 2A, so that means it's got a +2 charge. Okay. This means no dots because it lost 2 electrons. So then you're going to just write it the way we learned to write cations. So you're going to put Ca with no dots in brackets and a +2 charge on the outside as an exponent. So go ahead really quick, pause the video, and you try